Good morning, everyone, and welcome to the final press conference, which is not quite a press conference of this meeting. This is AAS 242, the 242nd meeting in Albuquerque, New Mexico. It is currently 10:15 a.m., and we are about to start a seminar for science writers titled Get Ready for the North American Solar Eclipses. So if you're here to get prepared for the next year, you're in the right spot. My name is Susanna Kohler. I am the press officer for the AAS, and I am assisted here today by Carrie Hensley, the deputy press officer, Ben Casses, the AAS media fellow, and is Sumit here this morning? Yep, right here in front. Sumit Kulkarni, the Astrobytes media intern for this meeting. So we have been updating the press kit. If you need any of the resources, materials for the previous press conferences, they are all up in the press kit as we've received them. So both the speaker slides that we've received, the press releases that have come out, and the archived videos from the previous briefings. So those are all on the meeting website. You can navigate to the press section, and then under the press kit, that's where you'll find all of those resources. And they're also linked from the Slack. So the way we're going to do this is we will go ahead and I'll give a brief introduction here and introduce our speakers, and then we'll go through and each of the panelists will speak in order. And then after that, we will move to the Q&A. For the Q&A, if you are watching us virtually via the Zoom webinar, then you can enter your questions in the Q&A box, and we will have someone in the room read those out during the Q&A session. If you're watching on YouTube, apologies, but we don't have a way to get your questions. And remember that when you do send in your questions, please identify yourself and your affiliation so that we know who you are. Okay, so today we have got with us here today, Angela Speck of the University of Texas, San Antonio, and the AAS Solar Eclipse Task Force, who's going to be presenting on the Great American Solar Eclipse Doubleheader. Next up, we'll have Rick Fienberg, former press officer extraordinaire and now AAS Solar Eclipse Task Force, telling us where to go for the best views and how to watch safely. Then we'll have Jayne Aubele from the New Mexico Museum of Natural History and Science, presenting on Albuquerque Prepares for its Day in the Sun. Then Craig DeForest of Southwest Research Institute and NASA's Punch Mission will tell us about From the Corona to the Heliosphere, Solar Eclipse Science and NASA's Punch Mission. And finally, Cherilynn Morrow from the Southwest Research Institute and NASA's Punch Mission will tell us about ancient and modern sun watching in New Mexico and beyond. And this is all in preparation for the 2 solar eclipses that are coming up in the next year. And I won't spoil that. I'll let them tell you all about it. So, Angela, let's get started with you.
I'm a lot shorter than Susanna. Hello, everybody, and good morning. We're going to be talking about these 2 solar eclipses that are coming. I want to start with something that I think most people in the room already know, but it's a good place to start, which is we get an eclipse when the moon gets directly between the Earth and the sun. Now, people often think that this is a rare event, but it's really not a rare event on a global scale. Actually, you know, the moon goes around the Earth and it gets in the direction of the sun every time it goes around, but it's only completely lined up between the Earth and the sun about twice a year. But that means we get an eclipse of some sort somewhere on the planet twice a year. So it's not a rare thing. It is something that happens very regularly, but in a given location, it is very rare. In fact, the average time between eclipses in a given location is 375 years. Now, there are different types of eclipses. Many of you will know that the Earth's orbit around the moon's orbit around the Earth is not a perfect circle. It is elliptical. In fact, at its closest point, which we call perigee, it's about 10% closer than it is at its furthest point. Now, if you bring something closer to you, it looks bigger than if it's further away. So at its closest point, it looks biggest. Many of you will have heard of the term supermoon. The supermoon is just the full moon that is when the moon is closest to perigee. That is, at its closest point, it's the biggest full moon of the year. But If you have a supermoon, that means the next new moon or the new moon before, when the moon is at the other end of its orbit, it's at its furthest point. Now, we get eclipses because the sun and the moon are approximately the same size in terms of their angular diameter, in terms of how big they look on the sky. But when the moon is at its furthest point, it's not quite big enough to block out the whole of the sun. And so we get what's called an annular eclipse, where you can still see the edge of the sun around the moon. It gets a little bit more complicated than that because, in fact, the Earth's orbit around the sun is also not circular. When we are closest to the sun, which actually happens in January, we're about 3.5% closer than at the furthest point. So in fact, even the size of the sun changes slightly over the course of the year. So depending on where we are in our orbit around the sun, where the moon is in its orbit around the Earth, we may have a perfect alignment where the moon is blocking out the sun completely, or we may get something where we still see the edge of the sun around. Now, I said that we get an eclipse every 6 months. In fact, the next 2 eclipses on the planet will be visible from the US, and the entire United States will see a partial eclipse. But what you're seeing here is this shows the path of the 2017 eclipse, which was the last US total eclipse. You can also see the path of the annular eclipse, which happens in October and is only 129 days away. And then the total eclipse, which is about 6 months later and is less than a year away. And these are the places where you need to be to see the total eclipse or the annular eclipse, but the entire country gets to see a partial eclipse. And just to give you an idea of what that looks like, the first eclipse to come up is the annular eclipse. That's on October 14th. And this is what you see. You're going to have, as the moon moves in the way and starts to block out the sun, you get a partial eclipse. And eventually the moon is directly in the way. And then we get what's called the ring of fire, where we can see the edge of the sun. And then the moon moves out this way and we see a partial. If you're not on the path of annularity, where you can see the ring of fire, you will still see a partial eclipse if you're in the US. But then 6 months later, April 8th of next year, we will see a total eclipse. The image you're seeing now was taken at the last total eclipse anywhere on the planet, which was this April, but it wasn't visible from the US. This was taken from Australia. And what you can see here is the beautiful corona. If you look closely, you can actually see there's some little pink sticky out bits. Those are prominences and flares that you can see from the surface of the sun. You can see this beautiful white corona, but you would also see during the total eclipse, you'll also see planets. It can get as dark as a full moon night. You may see stars if it gets dark enough. You'll also feel different. It gets cold. You think about what it's like when the sun is blocked out by a cloud and you feel it's nice and cool. Sorry, not really from the south. And it feels cooler. Well, now you've blocked out the sun much further up, and it can drop by up to about 10 degrees. And so you feel colder, there's breezes. You're also going to hear different things. Animals react, people scream a lot. And at the same time, you've blocked out the sun up here, but the sky is going to be lighter around the horizon, and there will be sunset colors all the way around the horizon. Now, for the eclipse in Australia, we only had 62 seconds to take all of that in. But for the eclipse in April, in 300 and some days, we will actually get up to nearly 4.5 minutes. So there'll be plenty of time to really enjoy this. And so just to finish off my remarks, the AAS, as this task force that was mentioned in the introductions, we have a website that has a lot of information on it, and that should give you all sorts of things that you can enjoy. Finally, this evening, there is a public event being held at the National Hispanic Cultural Center here in Albuquerque. It is completely free, and it will be a panel of speakers talking about both the science and the safety, as well as the cultural aspects of solar eclipses. And thank you.
Good morning, everybody. Susanna's watching to see if I can remember how we do this. Just waiting for it to launch. Okay, so I'm going to escape and go to presentation mode And it should be okay. Beautiful. All right, great. So let me just jump right in. I'm going to talk, Angela gave me a perfect setup. So now I'm going to talk a little bit more about where to go for the best views and how to watch safely. One of the task force's primary goals is to ensure accurate and consistent safety messaging from all the appropriate authorities, including, NASA and AAS and eye doctors and so on. So safety is a big issue. All right, so Angela already showed you a map of where the annular eclipse will happen. It crosses the country from Oregon to Texas. When you're trying to think about where you want to go, the first order decision is, I want to get into the path because I want to see what's special about this eclipse. And in this case, it's because we're going to get this ring of fire effect, but you're only going to see that in the path. But depending on where you are in the country, you could decide, I just want to drive the shortest distance, but there's another consideration, which is where are the weather prospects the best? And so this is a map from meteorologist Jay Anderson, who is an avid eclipse chaser, that shows the average percent of cloud cover at eclipse time across the southwestern US. And you'll notice that most of it's blue along the path, which is good. Blue is good, not too many clouds, and red is bad. And most of the path across the southwest is pretty good. So let me show you a more quantitative version, which is just a cut right along the center line. And you'll notice that Albuquerque has the best prospects statistically for clear skies on eclipse day, which is why the tour that I'm on and many other tours are going to be bringing people to Albuquerque. Coincidentally, October 14th of 2023 is the last Saturday of the International Balloon Fiesta. So it's going to be very exciting because there will be a ring of fire in the sky and there'll be hundreds of balloons in the sky. And somebody is going to have a balloon right in front of the sun at eclipse time. It's going to be terrible. All right. So you want to come to New Mexico. And for those of you who already live here, once every 375 years. All right, here's a map of the total eclipse path. And again, you want to get into the path if you can, because it's only within that yellow line that you can see the total eclipse. Otherwise, you'll just get a partial. And we're going to overlay the weather data again. And this time, there's a lot more red, orange, and yellow. And in fact, the only area that's really blue along the path is Mexico and southwestern Texas. Then you start getting into the green where you're threatening to go over a 50% chance of clouds. So, not surprisingly, the tours for the April eclipse next year are coming to Texas and Mexico. And specifically, again, you can see that Mexico is the odds-on favorite. Now, what's weird is that there's a saying among eclipse chasers, climate is what you expect, weather is what you get. And on April 8th this year, the pattern was like flopped. Mexico and Texas had less than ideal weather on eclipse day, and the whole rest of the path, including northern New Hampshire, where I live, was clear. But I am not going to take a risk and stay in New Hampshire. I'm going to Mexico. All right. Now, I'd just like to take a minute to try to impress upon you why you should go into the path. And I also want to just mention that I know that almost everybody in this room already knows this stuff. My point is to sort of model the things you want to say to your friends, family, and if you're a journalist, to your readers or listeners. Why should you get into the path of totality? What's the big deal? And Angela already told you, because there's all these interesting phenomena that occur. A good way to visualize it is to look at this plot of the change in ambient daylight over the course of an eclipse, from the beginning when the sun takes its first, or when the moon takes its first bite out of the sun, to the moment when totality begins. And you'll notice it's a logarithmic scale. At the top, we have 1 daylight. At the bottom, we have a millionth of a daylight. Very, very dark. And the curve goes from 1 down to about 1/100,000th. It's a huge change. But you'll notice that until you get to about 75% eclipse, you might not notice because your pupils can dilate by enough of a factor, about 4 in area, to accommodate, because this is taking an hour for the light to go down just 5, 6, 7%. And you're not going to notice because your pupils can dilate. It's not until you get to, say 85% that the daylight has dropped down to the equivalent of, midday shade. It's still a bright sunny day, assuming that there's no clouds. The annular eclipse in October will have about 90% coverage of the sun by area. And you'll see that we're now 7.5 minutes from totality. Even at just 5 minutes before totality, it's only as dark or bright as an overcast day. But you'll notice that in the last few minutes, and especially in the last 1 minute, the brightness plummets by 2 to 3 orders of magnitude. It took an hour and a quarter to go down by 10%, and then it goes down to a fraction of a percent in the last minute. It is only inside the path that you get that last drop, and it's only in the path that you see all these different phenomena and feel them. There is no such thing as a 99% total eclipse. There's such a thing as a 99% partial eclipse. There's no such thing as being 99% pregnant. It's all or nothing. So that's why you should get into the path. Now let's switch gears and talk about the essentials of solar eclipse safety. The 3 blind mice did not read the instructions. Okay, so who's this? This is your mom. What's she saying? Never look at the sun. Everybody's been told that by their mother. There is an exception. As Angela explained, during totality, it's only about as bright as the full moon, and so it's just as safe to look at. Amazingly, you can look at the totally eclipsed sun even with binoculars and telescopes, as long as you know how to tell when it's about to end. So here's the essential safety messaging. The sun at any other time, no eclipse, partial eclipse, annular eclipse in October here in New Mexico, you must not look at the sun without protection because it is dangerously bright. Okay? So there will be no time this October when anybody can look directly at the sun without eye protection. To observe the sun at any of these times, other than during the total phase of a total eclipse, you can look directly through special purpose safe solar filters or indirectly using pinhole or optical projection. And so as Angela shows, this is, you can pick up some of these at our booth, the AAS booth, some eclipse glasses. When you fold them, then if they don't fall on the floor, you can put them on even over glasses. I can't see you anymore because these block an awful lot of light. They now make plastic ones, make you look like Geordie LaForge. They come in cards with and without lanyards. They're very cheap. And if you're careful about where you go in the exhibit hall, you can pick up samples of all of these. All right, what about really, really dark sunglasses? Are they okay? No, they are not. Regular sunglasses just block tens of % of the light. They are thousands of times too bright. Solar filters are so dark, again, they block all but about 1 part in 100,000, not coincidentally the same as the diminution of sunlight. They also attenuate ultraviolet and infrared radiation. And the ones that we label as safe, or that we call safe, are the ones that comply with an international standard that was adopted in 2015 called ISO 12312-2. And so if you know that your filters meet that standard, you know that they're safe. I'll say more about that in a second. One point I'd like to make is that media articles often say you need to wear sun protection glasses because otherwise your eyes will be injured by the solar ultraviolet and infrared radiation. The main threat is actually the visible light, mostly the short wavelength. If you look at the solar spectrum, it peaks right where our eyes are most sensitive, a consequence of the fact that we evolved under the sun. And all these filters attenuate across most of that spectrum. But if they don't, you're going to get the most light in the short wavelength bluish light. That's the stuff that's going to hurt your retina. And it's not a burn per se, it's a photochemical reaction. Usually you can recover from it. On the other hand, if you were to look through binoculars or a telescope, the amount of sunlight being concentrated would be so intense that you would not only get a photochemical injury, but at that point, concentrated from a lens or binoculars or something, you will get a retinal burn, and that you cannot recover from. So how do you find these safe solar filters? You start on the website that Angela pointed out, the task force website. You look in the eye safety section, and we have a page on suppliers of safe solar viewers. Now, we don't test solar viewers ourselves, but we examine the documentation from the labs that do test them, make sure that the lab is accredited to test against that ISO standard, and make sure that the transmittance and other properties of the filters do pass, in which case we then list them on our page. So if you go to any of the suppliers listed on our page, and there's at least one who's here at the AAS meeting, you're in good shape. But one problem we saw in 2017 was that right before the eclipse, they were all sold out and people started freaking out. So one point that's worth making is that the partial phases of an eclipse, they last more than an hour. It's not like you're going to put these glasses on and stare at the sun for an hour. So you can share them. As long as you got one pair among a family or a group of friends, you're good. Just pass them around and everybody takes a look every now and then. You can't see the sun change in real time during the partial phases, but if you look every few minutes, you can see that it's changing, that the moon is moving across. And again, you don't need to worry because you can go to the exhibit hall and pick up some of these AAS and Sky and Telescope glasses. But otherwise, or if you need more, or if you don't have them, go to this website, find out where you can buy them, and then get them. Now, again, I want to stress that you should never look through optics wearing these things. Solar filters always have to be the first thing that the sunlight hits. So if you were going to take pictures through a camera, you want the filter in front of the camera. If you're going to look through binoculars, in front of the binoculars, and so on. So it's very important safety tip. Do not wear those while looking into an unfiltered telescope or binoculars because it'll melt the filter within seconds and the sunlight will go into your eye. All right, so we're almost finished here. The AAS website, again, it has all this messaging, and I'm very proud that we're co-branding a safety flyer that carries the NASA, AAS, NSF, and NOAA logos. We're all sharing the same message, and that safety messaging has been endorsed by the American Medical Association, which never used to endorse this kind of thing, but they're endorsing our messaging, and all the major US and Canadian and hopefully soon Mexican associations of eye doctors. Now, there are other ways, as I mentioned, pinhole or optical projection. I don't have time to go into those right now, but if you put the sun at your back and you have some kind of projector, you can either through a pinhole or through optics operated properly, you can view the sun indirectly, in which case you don't need filters at all. So to find out more about that, I refer you to the website. Again, we have our main safety page as well as a page on projection, both pinhole and optical, and how you can make your own or buy optical projectors or even pinhole projectors. And I know Cherilynn will talk more about that. And we also have a page on how to use solar filters with optics. All right, thank you very much.
Certainly.
Good morning. I am from the New Mexico Museum of Natural History and Science here in town, and we are part of a group preparing for the eclipse. Now, as you've heard, Albuquerque will be ground zero for the annular eclipse, and we'll have a partial eclipse when other folks are having the total next year. But this year, we will have an annular eclipse, and Albuquerque will be the perfect place to see it. We actually had an annular eclipse about a decade ago visible, in Albuquerque in 2012. And the image you saw on the title side and this image were both taken during that time. So we're very fortunate to have two within a decade. But after that, if you miss this year's, you're going to have to wait until 2238 for the next one for Albuquerque. In Albuquerque, the annular will begin around 9 a.m. It lasts almost 3 hours. Full annularity, the ring of fire, will last a little more than 4 minutes, around 10:30 in the morning. And that means the sun in Albuquerque will be fairly high in the sky to the east. The last time it was low on the horizon to the west. So we were able to get some wonderful scenic photographs. This time it will be a little bit more tricky to get objects in front. And just about every place in Albuquerque will be able to see it if they have a view to the east. The other thing is, yes, it is the last Saturday of Balloon Fiesta, which means last time 50,000 folks showed up just for the eclipse, plus the 100,000 that will be expected to be here for Balloon Fiesta. However, I do have to caution, by 10:30, most of the balloons are down. So you may not get a shot with lots of balloons in the sky, and you may want to be elsewhere in Albuquerque. Because Albuquerque is ground zero, we've had lots of national large organizations contact us to come to Albuquerque to do viewing, do live streaming, and help get the word out for programming. And these are just some of them: NASA, Astronomical Society of the Pacific, NOAA, the Park Service, and the Punch Outreach Collaborative. And you'll be hearing more about that later. But this is an major outreach effort associated with several NASA solar missions. We in Albuquerque have been meeting and putting together a coalition of partners who will provide educational programming and viewing sites. And many of us, if not all, are being helped by the Punch Collaborative. So here are some sites. Of course, the New Mexico Museum of Natural History and Science, the International Balloon Museum in Fiesta Park, and Petroglyph National Monument will all be having NASA and in some cases NOAA presence on site. National Hispanic Cultural Center, City of Albuquerque Parks and Open Space, New Mexico State Parks. Everyone with open space is expecting people. Schools are involved in this effort. University of New Mexico and SIPI here in Albuquerque, our Southwest Indian Polytechnic Institute, are planning some viewing events. CNM, Native American Community Academy, the Forest Service in the Sandias, unlike last time, when people lined up along the top of the Sandias with a view to the west. The Sandias may not be the best place this time, but perhaps some of the sites in the East Mountains. Other museums in town, all over town, and even nearby locations are part of our coalition in Santa Fe, in Rio Rancho, in Placitas, and farther afield, El Malpais, BLM. They're planning some fun stuff near La Ventana Arch. Pueblo of Acoma, Jemez Historic Site, and of course, the VLA. And even farther afield, regionally, Chaco, El Morro, and Mesa Verde are all part of this coalition and the sponsorship by the Punch Collaborative. So, lots of places to go for more information. And any of the local coalition event viewing sites, websites. There are some other websites listed here. We will all work very hard in the next several months to prepare Albuquerque and New Mexico to view it safely, understand what's going on, and have fun. So I encourage all of you to do the same.
There we go. Thank you. Hi, I'm Craig DeForest. I want to talk to you today. You heard a little bit about places to view the eclipses that are coming up around and some of the activities for the general public. I'm going to talk a little bit about some citizen science that we can do during the eclipse and also about punch, which is a word that you've heard a few times, and what it is and why it's relevant. So we'll start with Citizen Kate, and I notice on this slide, I didn't actually get what the acronym stands for. It's Continental American Telescopic Eclipse Experiment. And so Kate is a citizen science effort that is being led by Southwest Research Institute, but is a collaboration between many institutes funded by both NASA and the NSF to observe the corona in unprecedented detail and see how it evolves over the course of the eclipse. This year there was an initial run in 2017. Coming up in 2024, we're deploying telescopes with polarization, which allows us to measure the 3D structure of the corona as it changes across the course of the eclipse. We have multiple sites. The important thing about Kate is there are many amateur-run telescope sites that are all identical, or as identical as we can make them, so that we can merge the data into a single hour-long virtual eclipse. And that has benefits for direct science, but also for the punch mission. I'll talk about that in a moment. This is an image from the April 20th eclipse down in Australia earlier this year. I want to call your attention to the pseudo color. This is actually a black and white image. And we've used color to encode the direction of polarization and the degree of polarization of the light, which allows us, again, to measure the 3D structure of the corona. I won't talk about the physics of how that works, but it allows us to get a 3D image from a single viewpoint, which is really phenomenal. You've seen maps like this before. This is a map of totality. What I want to call out here is the start and end times of the eclipse crossing the United States, 1830 UT to 1935 UT. It's a little over an hour. But the duration of the totality is up to 4.5 minutes, a little less than that at all locations. Well, the solar corona doesn't evolve very much in 4 minutes. It's a very large thing. But it does evolve noticeably over the course of an hour. And so there's a lot of science we can do by measuring how the corona changes over an hour that we can't do in 4 minutes. So the way we address that with Kate is by deploying 40 telescopes along the site. And the idea here is that we'll have telescopes that are as identical as we can make them, and we'll make use of ground software to merge the data afterward. So we are seeking out, we're right now actually recruiting teams, qualified volunteers. There's a contact email address down below, kate@boulder.swri.edu. And we provide equipment. We'll provide the exact setup that will be used to each team so that we can ensure that it's identical. And as a result, we'll get an amazing, I want to say unparalleled, because it's the first time this has been done with polarization. highly detailed movie of how the corona evolves over the course of this magical hour. So here are some examples of teams setting up the demonstration equipment. And again, that email address, if you're interested or have readers who may be interested in volunteering. So that is Citizen Kate. I'm going to pivot now to Punch. Punch is a mission that I lead actually for NASA. It's a small Explorer mission. We've got the what, when, where, why, how, and who here. So we're preparing to launch 4 small satellites into orbit. We'll launch in 25 from Vandenberg Space Force Base to track the corona in 3 dimensions. We'll be doing almost the same kind of imaging that Kate is doing with different equipment, of course. But we'll be trying to understand how the sun produces space weather and the solar wind. So we'll be examining the same structures that you can see during the eclipse, but with much wider field of view to see how they stream over the Earth. And so we're very excited about it, of course. It's not directly relevant to the eclipse because we'll be launching after this eclipse, but some of the same techniques that we're developing to be used for Punch, we're going to use for Citizen Kate. And so this is a great example of citizen science synergizing with a large NASA mission, that the techniques that we develop for Kate will be directly applicable to Punch. And in fact, we're using some of the same code, and we're using Kate to vet the Punch pipeline for flight. So just to give you a sense of what Punch will do, what you see on the left here is a log scale movie of features on the sky that were seen with an earlier mission called Stereo. It's a precursor to Punch. Stereo was ahead of the Earth, Stereo A was ahead of the Earth in its orbit, and observed a coronal mass ejection, a space weather event forming on the surface of the sun and propagating across the solar system to impact the Earth. And so what you're seeing here is polar coordinates, so you have to get your bearings. The blue straight vertical line on the right-hand side of that movie represents the limb of the sun, and that's an actual photograph has just been distorted into these polar coordinates. And the scale is logarithmic, so the 1 degree corresponds to the size of your thumb at arm's length, right? 10 degrees is the size of your fist at arm's length, and the left side of this movie is fully 90 degrees away from the sun. So you're really seeing an event that's swept across the entire solar system. Punch will be viewing events like this from near Earth with polarization, so in 3D, and without the seams that you see in this movie. Furthermore, we'll do it in a full circle instead of just near the plane of the ecliptic. So we're very excited about that science, but I'm not going to belabor that more now. I want to get into the techniques that we use. Punch has 4 satellites because there's a ruddy great planet in the way. And so we had to spread out around the planet in order to be able to see the entire inner solar system and photograph it every 4 minutes. So we have 4 fields of view: an inner field of view from our narrow field imager, or NIFI, narrow field imager. And we have 3 copies of a wide field imager called WIFI. And those 3 copies spread around the planet, as you see in the image. They're orbiting over the dawn-dusk line so that they're always in the sun and they can always see. And they spread out around the planet so that all directions are up for at least one of them. And so as they orbit, you can see this trefoil on the night sky spins around. For scale, you can see Orion down there on the lower right of the movie. That's sort of the corner of Orion and his belt. As these spacecraft orbit and assemble these large mosaics, which we then merge on the ground to form a single virtual instrument. And of course, we're using Kate to demonstrate that. So I want to give you a sense of just how big this field of view is. This is a Druckenmiller image from the 2017 eclipse, just sort of giving you a sense of the kind of detail we'll see during the eclipse. Here's an image that was taken by a colleague of mine, Dr. Emil Kepko in Salem, Oregon, showing the eclipse sort of in a typical view with some trees and so forth. I'm going to overlay that with the Punch field of view just to give you a sense of scale. There it is. So Punch will view everything from the horizon to the zenith if the sun is 45 degrees above. It's an enormous field of view. We have some labels here. So the idea here is we are not a telescope. We're a wide field imager that's examining the solar wind, the material that's streaming out of our star and out into the void and over the Earth. We will image that every 4 minutes for our 2-year prime mission. And we launched in 25. I talked about Punch Kate Synergy. We have a very large outreach program that we're very proud of, and I will defer talking about that to Dr. Cherilynn Morrow, who's up next. Thank you.
Good, I can see that. That's nice. Excellent. Thanks. Good morning, and thanks for being here. I see some familiar faces that I'm happy to see, collaborators. I'm Cherilynn Morrow, and this is the title of the contribution I will make this evening to this public event that was mentioned by Angela at the beginning. I really encourage you to be there. We're going to have some cross-cultural voices. It will be a fairly unique program, and I encourage you to consider it at 7 o'clock tonight. I got my start in New Mexico as a graduate student observing the sun, and at Sacramento Peak Observatory above Alamogordo, New Mexico. And that was in the, I hate to say it, 1980s, right? So way back when, gathering PhD astronomy data. So I'm a solar physicist by training, academic training, an educator by a cross-cultural educator by heart, and a songwriter by soul. How's that? And so I am loving this outreach program that we have developed, which connects what you just heard described by Dr. DeForest and the eclipses and the enormous 1,000-year-old legacy of sun watching of the US Southwest, and especially in New Mexico. I've also spent time as 15 years off and on as a volunteer in Chaco Canyon. And so when Dr. DeForest, the PI, said, I want an outreach program that you would love to implement, the natural thing to do was to make an ancient and modern sun watching theme out of our outreach effort. So our motto then is shining new light on diverse views of the sun with our ancient and modern sun watching theme. And there you will see, even in this brief little presentation, those different aspects of what diverse views might mean. I'll quickly say something about what our ancient and modern sun watching theme is. It has 3 elements that we weave together. The NASA heliophysics missions, not only Punch, but Parker Solar Probe. I'm sure many have heard of the solar probe that's flying in the solar corona. So while Parker is flying in situ in the solar corona, Punch is seeing that big picture view. So that idea of different perspectives plays in both a scientific and a multicultural sense. Our focus for ancient sun watching is none other than Chaco Canyon, a World Heritage Site with tons of world-class evidence. It's just 3 hours down the road here. We took a pre-conference group to Chaco for a day trip. There is world-class evidence of ancient sun watching and alignment of monumental architecture. So it's a great example, not only for the region, but also for the world. It's the US's, pyramids, effectively, to go there. So we are portraying NASA exploration of the sun as a natural extension of a long-lived dedication humanity has shown for observing the rhythms and mysteries of the sun, right? And so there's the connection. And that also makes it, as we invite youth and families and others of our collaborators to their own way of personal sun watching, that actually has a way of connecting NASA heliophysics in a personal and culturally relevant way to more diverse learners than might otherwise pay attention. That is our quest and our hope in collaboration with many people. So here are some of the populations we're collaborating with and learning from. Punch Outreach endeavors not to have target audiences. We have collaborators and we learn from them, and we endeavor to be of benefit. So Native American and Hispanic, Latinx, youth and families, blind and low vision learners, girls in STEM, and these dimensions in this crowd here are people that you might think wouldn't like to pay attention to eclipses, but in fact, blind and low vision learners have ways to pay attention. The sensing of heat on their bodies, or the use of tactile art objects that we're developing in collaboration with them that are of benefit to both them and also to sighted learners. And I'll just leave this around if anybody wants to come and have a sample of what that's like. Also, there are some cultures that don't want to look at the eclipse. So you might think, well, everybody wants to jump up and down and scream and be excited and have fun. But there are cultural sensitivities that we need to be looking out for in the US Southwest. Not everybody. Some people will be inside fasting and praying and being reverent. So there's the entire mix, and you'll hear about that in this evening's program if you come to see us. As many of my colleagues here, I'm collaborating with all of you, right? And we're all going to be there tonight, as well as these other voices. And Jayne already did a marvelous job of telling you the incredible list of people that we're supporting with either products or people. You can walk away with a few of these if you would like. This is our 3-hole punch pinhole projector. Right? And there are 3 holes in it of different shapes rather than just one round hole. And it makes this projector useful even when the sun is not eclipsed. Yeah, you can have some fun with it. When you have it close to a projection screen, you see the triangle, square, and circle as you might expect. When you pull it away, it begins to image the sun. And so that all of those holes turn into round images is quite enjoyable by young and old. And so I encourage you to, these are available for printing on the website. And also we are printing 100,000 and shipping them around to our friends and collaborators. Derek, I think you got one of those, and we'll find a way to get them to Franklin Institute too. All right. In collaboration with the New Mexico Museum of Natural History and Science, you see there these eclipse, we don't call them eclipse glasses, we call them solar protection glasses, in deference to people who might be willing to look at the sun when it's not eclipsed through them. And I'll tell you that these are a great companion, because when a young person sees the round images form and then looks at the sun and sees how boldly round it is, which you can see through these glasses, this is a lovely 1-2. You're on the ball. We did, on May 20th, we did a marvelous Sun Fun Day at the Pueblo of Acoma, and really incredible engagement. And this prominence showed up to help us celebrate the sun. And we learned a lot about the various activities that we've been developing. And again, making that personal and cultural connection between NASA missions and the heritage of sun watching here in the Southwest. And again, that was focused on Chaco culture. We were there this past weekend doing additional photo documentation and giving astronomy educators from this conference a taste of Chaco and the so-called Eclipse petroglyph site. This is a site that's 1 kilometer due north of Fajada Butte. Some of you might know the famous butte in Chaco Canyon that has the sun dagger on top of it, right? And so the sun dagger is a rather well-known around the world special way of light and shadow falling on a spiral. But this site has it all, has horizon events, it has light and shadow on spiral, and it has this unique petroglyph that we have become very fascinated by, and we're using it as a conceptual portal between NASA heliophysics. It may well be, it has been interpreted by a credible cultural astronomer as a eclipse at a time of high solar activity. And basically, there was a 1097 eclipse. It was at a time of high solar activity. Venus was off in this direction. Oops. Right? And so there's this other similar pecking that goes on here. And as I mentioned, there was a lot of other types of horizon and shadow on spiral going on either side of this site. So a lot of circumstantial evidence for a solar interpretation of this petroglyph, and we got to see that on our trip there. And of course, this is a historical dimensions. The petroglyph may be before the 1860 hand drawings that are typically written up as the first evidence of solar activity in the corona. Maybe it's this petroglyph instead. And in 2017, this interpretation was picked up by Smithsonian and Scientific American. So we think it's worthwhile to raise it again. So you see petroglyph, hand drawing, painting, ground-based photography, this composite photography such as Craig showed, and NASA spacecraft imagery, and onward from there to Punch and beyond. There's just a lovely picture of some of the tactile art representations of the corona that we are making use of with blind and low vision learners and with sighted learners. There's also a 3D printable that you all will be able to have access to of this petroglyph to make it a part of your story for eclipse events. And then the archaeologists are getting in on it too, not just the cultural astronomers. This pottery bowl is the same size as our hand, as is the petroglyph. And we get to go to the Maxwell Archives at the University of New Mexico this next Tuesday and search for more of this pottery motif, which has obvious resemblance to this piece of rock art, this petroglyph. So thank you for listening. We're inviting all New Mexicans and all people to safe sun watching during the eclipses, along with heightened awareness of this rich world-class historical cultural heritage of sun watching that this region exemplifies. So when you watch eclipses yourself, think about that human heritage as well as NASA spacecraft flying in and around observing our solar corona, and make that connection to your now.
Wonderful. Thank you so much to all of you. While I get this moved back over, let's go ahead and go into questions.
Thank you. Excuse me. Thanks. So I think, as Rick pointed out, and also I think that XKCD cartoon kind of makes this point well, is that a partial eclipse, including an annular eclipse, is really quite boring compared to totality. So I wonder that while we want to encourage people to see the annular eclipse, is there the danger that people that do see the annular eclipse may not be inclined to travel to totality because they don't appreciate the difference that totality offers? They think they've already seen it the year before. So
I agree we need to be really careful with the messaging. I think this is something we're really trying to achieve. It's both the annular, but also getting people to realize, as Rick was talking about, 99.9% is not good enough. And I think view graphs like the one that Rick showed, which shows the light, is really useful. And you can really tell the story of, if you're, for instance, where I am in San Antonio, downtown San Antonio will not see totality, but where the university is, we will. But the zoo gets 99.98%. It's not enough. But that's how you can then get into the story. And part of it is just making sure you just keep sharing that information. And I think it is important to say, I've seen an annular, I've seen a few totals, that those of us that are telling the stories are making that point.
I'd like to add to that. They are two very different experiences, I would say. And they need to be almost packaged separately, not just eclipses, but the annular eclipse is really quite dramatic and beautiful. And seeing that ring of fire, it's a totally different experience. You don't get the darkness, you don't get the cooler temperatures that you get with a total. You don't get the sort of black hole effect. But what you have is the ring of fire effect, which is really quite remarkable in its own right. So I would say almost keep them separate. Annular eclipse, total eclipse, almost two different animals, so to speak.
John Keller, University of Colorado Boulder Fisk Planetarium, and collaborator with the Punch mission. Just a comment and then a question for Craig. Comment, I really appreciate, Angela, your perspective on the orbital mechanics of how all of these eclipses work. And it's actually a teaching opportunity to teach about lots of planetary alignments that we can use for doing astronomy, like occultations, where objects in our solar system pass in front of stars, and transits, where other planets pass in front of other stars. And so that's an interesting opportunity to think about that as a teaching moment for the public, which will be very excited about this. We have a Science Through Shadows science activation grant that is doing that through planetarium films. So happy to hear more perspective from Angela. Craig, a question for you. Philosophically or poetically, I was struck by the 4 minutes of totality, and I believe a 4-minute cadence of how quickly Punch will take images over its lifetime. Can you wax poetic on that for us about how those 4 minutes are cool?
Thank you for that. So yep, we in fact picked a 4-minute cadence for Punch because that is a duration that doesn't matter in the corona, right? So that's a highlight in this sort of convergent evolution, right? That the 4-minute totality is a snapshot. You will see a snapshot of the corona, and we can corroborate that because we looked at time series of data and decided that was short enough for the Punch mission. In the time-honored tradition of press conferences, pivot on that and point out folks who look at the corona for those 4 minutes will see what electrons look like, right? Which is to say, the corona, the part of the corona you see is the electrons. So if anybody ever asks you what an electron looks like, that's it.
Add to that the 1097 eclipse was about 4 minutes. And yeah, and one of our Aqua Pueblo collaborator loves to think about how they didn't have a photography and drawing in the same sense that we did, and they were observing for that amount of time and may have witnessed something that inspired to create petroglyph back in the rock art. And then how would you have done that perhaps communally? What did you see? What did you see? You know, what should we render here, right? So it's a very different way of capturing data about what one saw. And I hadn't made that connection 444 before. So thanks, John. Yeah.
I was going to add something. So when we talk about how long the duration is, I didn't really have time to get into this, but there are many different factors that lead into how long you get in totality. As I mentioned, the Australian eclipse at its longest was of the order of a minute. But how long you get also depends on where you are on the path. The longest duration anywhere on the path is going to be in Mexico. And the further along the path up towards New York State, it's going to get less and less time, just by a little bit. But it also matters where you are across the path. You're only going to get 4.5 minutes if you're in the center of the path. And if you're at the edge, you get much less time. So as I said, downtown San Antonio does not see totality at all. Where our campus is, we get about 2.5 minutes because we're not right in the center of the path. So when you're thinking about where you want to be to see this and where, who the people should be that are doing, say, the Kate observations, being close to the center gives you that longer duration.
I want to respond to what Cherilynn said too, because when I'm leading an eclipse tour, after the eclipse, we all gather together and do exactly what you described, because nobody can see everything, because things are happening, as Craig explained, on different scales. So if you're looking at the corona to see all the detail in your telescope, you're not seeing the bright planets in the sky. And if you're looking at the ground for shadow bands, which is like the twinkling of the thin solar crescent, if you're looking on the ground for that, you don't see the shadow coming. And so the only way to get a true sense of what actually just happened is to get everybody who was observing it together and get all those different perspectives, different fields of view, different directions of viewing, different magnifications, that kind of thing. Of course, they didn't have magnification back then, but still, that's how you figure out what was that. No one person can tell you. It's like the blind man and the elephant.
I'm going to go ahead and let this run a few minutes over, assuming you're all able to stay a little longer. Yes. Okay. Let's go ahead. Doug?
Thank you. Hi, Doug Duncan, University of Colorado and the Fisk Planetarium. I'm kind of a segue to what's just been said, and answering the question about how do you keep separate messaging for the annular eclipse and the total eclipse. We have a nice NASA grant to produce free videos and disseminate them to museums and schools and whatnot. And if you Google Fisk Planetarium, you'll see them. We let people speak, particularly in our total eclipse video. These are about 3-minute videos. You can use them however you want. They're also in English and in Spanish. We just went out and found people who had seen their first eclipse. What did they expect? And then afterwards, oh my God, it was so much more. Just let them put it in their own words. And, you know, with maybe 6 really short interviews in the videos, you can see the range of ways people respond. And sometimes it's very analytical. Oh, it got so dark and I could see planets. Sometimes it's very emotional. It looked like the end of the world. I was scared. My own daughter, who saw an eclipse when she was 12, she goes, "Dad, that was scary fun." So we put those into our Fisk videos and they're free. So just Google Fisk Planetarium Productions and make use of that.
Just to follow up on that, there's also a selection of videos that would be complementary to those from Fisk, which are being produced by University of Texas at San Antonio, where we're making short videos of the order of 2 minutes, where it's explaining the durations, the how often are eclipses, why eclipses happen, or some of the history, again, both in English and Spanish, because South Texas is largely Hispanic. And just to address this issue of separating the 2 eclipses, not where I live, because where I live, we get both. So we actually have to address the issue of, that people are going to see both of them.
Good. Let's start with back there, and then we'll go one more in the back of the room, and I think we'll have someone online.
Thank you, Jennifer Wiseman from NASA Goddard Space Flight Center. I have a question mainly for Rick, but for anyone. For those of us who plan to go to a site for the total eclipse in next April, and I'm going to my home state of Arkansas, but if, unfortunately, as you projected, the weather turns out to be not ideal, can you recommend a backup like video site that we can have ready on the internet or something to watch the eclipse if we get clouded out in real time?
Yes, as Jayne pointed out, NASA is going to be webcasting the total eclipse from all along the path. And they do that because it may not be clear everywhere, but the more spaces that they're able to see the eclipse, the longer they can broadcast and the more people will get to see it that way. So that's one site. The Exploratorium almost always also webcasts, and then there's a lot of amateurs and other eclipse chasers who do it too. But those are the 2 places to start.
And then the city of Waco, which is, right next to Dallas. So far enough north that the weather might not be great, but the Discovery Channel is partnering with the city, so they'll be broadcasting as well.
And I also want to mention that even if you get clouded out, which has happened to me twice, it's depressing, but at the same time, you are in the moon shadow. It does get cold. It does get dark. People are freaking out. Animals behave differently. So it's a shame if you don't get to see the corona, but there will be another total eclipse. But you really will still have a pretty awesome experience. And what really drove that home for me was that the last eclipse tour I was on, we got clouded out. And when I canvassed the the passengers to find out, what their responses were. The people who had never seen an eclipse, a total eclipse before, still thought it was the greatest experience of their lives.
And
Hey, this is Milo from UC Berkeley. Question, none of the two solar eclipses stop at the southern border of the US. Are there any plans to connect with collaborators from the continental American, considering that the main two paths crosses countries like Mexico, Brazil, Colombia, and crosses places where they are known to have underserved communities?
So the Eclipse Task Force has membership from the US, Canada, and Mexico. We have a workshop. It's one of a series of workshops that we've been conducting since before the 2017 eclipse here in Albuquerque this coming weekend. And some of our presenters are from Canada. We have someone from Brazil. So there's a lot of communication. That's the other major purpose of our task force, is to connect all these communities and stakeholders so that they all know what each other are doing and can benefit from the things that each other are developing, like the videos that Doug and John described and that Angela described. So there's a lot of, it's true, the reason that we're emphasizing North America is because that's the principal constituency of the American Astronomical Society, but we are nevertheless connected, with Mexico and Latin America as well. And we're going to endeavor, the safety sheets that we're going to have on our website for download will be in English, Spanish, and French. And the Brazilians, I know, are going to translate that into Portuguese as well. So we're definitely doing the best we can with that.
And like I say, there's materials like the stuff that Doug was talking about and the stuff that we're doing, in the Southwest, there's a large Hispanic community. So even within the US, we're producing materials that will work for most of Latin America. I don't know how many are being also put into Portuguese. And then there's groups like Astronomers Without Borders, who frequently will go to those underrepresented areas and take with them both the indirect and direct viewing opportunities.
And for Kate, there are additional logistics to going international, but I know that the team is discussing trying to extend down into Mexico.
in fact, I think that David Elmer is going to be down there, and there's a NASA webcast from Mazatlan as well. And this will be in Spanish, and at least around there, probably disseminated quite a lot. But we should talk more. Milo, who is the Solar Physics Division Education and Public Outreach Committee lead. And so further conversation is due.
And locally, of course, our National Hispanic Cultural Center is one of our partners.
And that's the location of the event this evening. Yeah.
Let's move to our one question online, and then we're going to have to wrap this up. Sorry.
I have a question from Andrew Fracknoy of OpenStax Astronomy. I presume this is for Rick, but anyone can answer. Can you talk a little bit about projects that provide safe eclipse glasses for the public nationwide? Oh, we've got a laugh.
Sure. Yeah, there are several projects that have been funded either by NASA or by foundations, such as the Moore Foundation, to distribute millions of eclipse glasses or sun protection glasses across the US via, for example, public libraries. And there's a program by where NASA funded the Astronomical Society of the Pacific to create an Eclipse Ambassador Corps, which is partnering college undergrads who are interested in eclipses and science with amateur astronomers, and to supply them, not individually, but as teams, with hundreds and hundreds of eclipse glasses. And so there are lots of these, not lots, but there's a good handful of programs that have been funded to combine engagement with the public with the distribution of safe solar viewers or pinhole projectors, and with all the proper safety instructions, and with booklets of activities. For example, this library program that Andy's mentioning, they've developed booklets for educators, booklets for school administrators, booklets for outreach providers. This is all being provided for free because it's all funded. And we'll reach, I think it's 10,000 public libraries. The Eclipse ambassadors, there'll be 500 teams in 500 different communities across the country. So it's really great because there's a lot of mobilization of educators and outreach providers and STEM engagement people to meet the public where they are and make sure that they are prepared to observe the eclipses if they want to, and to do it safely and enjoyably, and also to be inspired by the eclipses and also to learn about the kinds of things that Angela and Craig were talking about, why these things happen, what's going on, what's the solar corona, and so on.
And here locally, thanks to Punch, we at the museum will have an estimated 100,000 pairs of either glasses or viewers to distribute over the next period.
And they are called solar protection glasses,
Yes.
and they don't have an image of an eclipse on it out
And
of
they
cultural.
also
respect.
do not have the word eclipse on them. They are actually called solar protection glasses.
Exactly.
All right, thank you so much. We're going to go ahead and wrap this up. One more round of applause for all of our. Did one of you want to make a last minute plug for tonight's event?
There's an event tonight. So it's at the National Hispanic Cultural Center. It's at 7 p.m. and it will be some of the speakers you've already heard, plus members of the Indigenous community. And you'll get to hear both cultural and scientific and safety, and it'll be awesome.
Great. Thank you so much to all of you. Thank you to all of our presenters this week, all of the PIOs who worked with them on press releases. Thanks to all of you for having been here. And we will see you all.
Thanks to
Also, thanks to
Susanna.
USRA for sponsoring us. And we'll see you all in New Orleans, hopefully.